Okay, so the last video was introducing the inverse sine functions, and now we're just going to do a bit of work, just having a look at how to deal with things. Okay, so just some little examples. What is sine to the -1 of negative root 2 on 2? Let's try and figure out what this is equal to. I'm just going to draw my circle over here. Always draw circles. Okay, what this is asking for is where is sine of x equal to negative root 2 on 2. In other words, where's sine equal to root 2 on 2? So if you look at this, it's root 2 on 2 happens only at the sort of the 45 degrees. Okay, so there, and there. And just remember that our sine function is restricted to negative pi on 2 to pi on 2, so in this range here. Okay, so that's where we're thinking about it. Where is this function equal to negative root 2 on 2? Well, up here, sine would be positive because y is positive, but down here it's negative, so it must be down here. It needs to be in quadrant 4, and so therefore it's equal to negative pi over 4 radians. Okay, so that's your answer for that. Okay, let's go again. Let's try another one. Let's do cos -1 of a half. This is asking you where is cos x equal to a half. Okay, so again, draw a circle. Okay, and we're looking at cos. Now, just where's cos restricted to? Cos is restricted to, it's different to sine, is restricted to there and there. Okay, so we need to figure out where's cos x equal to half. Cos x equal to half happens only at up here at 60 degrees, or pi on 3, or up here, which is its reflection, at sort of 120 degrees, or 2 pi on 3. Okay, so which one is it? Well, there cos it would be negative, so that would be a negative half. Here it's a positive half, and so it must be pi on 3, which is your position there. Okay, and do another one. Tan -1 of negative root 3 on 3. You might go, I've never heard of this root 3 on 3 before. What is that? We'll just rearrange that. What that is equal to is if you divide by root 3 on 3, it's actually equal to -1 on root 3 if it's an unsimplified set. If you figure that out, that's actually equal to that if you divide everything by root 3. Anyway, times that by root 3 you get 3, times that by everything. So just check that, there's your value. Let's draw a circle. Where is the tan function? The tan function is restricted to negative pi on 2 to pi on 2, so it has to be somewhere in that range. So what have we got? Well, tan will be 1 on root 3 at 30 degrees or negative 30 degrees. Okay, you'll get those types of numbers. We want tan -1 on root 3, and so where is tan going to be negative? Tan is going to be negative down here. Okay, that's where you get your negative tan number. So that will be equal to negative pi over 6 radians. There's your answer to that. So that's a bit about how to work these out. Hope you get good at that, because you're going to get a lot of those sorts of things. Secondly, find the domain and range of the function y equals sine 2x plus 2. Okay, find that. Okay, so just recalling what the domain and range of the let's have that in there, otherwise it makes it quite easy. Sine -1 2x plus 2. You remember that if we've got y equals sine -1, the domain for y sine x, the domain of this function is -1 to 1. Okay, they're the possible x values, and the range goes from negative pi on 2 to pi on 2. Okay, so let's just remember that. Okay, so if our x values are allowed to go between -1 and 1, for this function up here, that means that 2x plus 2 must be between 1 and -1 as well. Okay, I'll just say that again. If for this value to be restricted to this domain, it means the values of x must be between -1 and 1. That means for this function here, again, 2x plus 2 must be restricted. 2x plus 2 cannot be less than -1, cannot be bigger than 1. So this inequality must be true here. So we'll just solve this. So therefore, add 2 to everything, you get 2x less than or equal to 3. Sorry, subtract 2. What am I doing? Subtract 2 from everything, so -1, -3, and divide everything by 2, you get x, -half, -3 over 2. So there's your domain. Therefore, domain goes from -3 on 2 to -half. There's your domain. And the range, well, the range, nothing happens. These are just shifts in the x direction. So your range will be. What am I talking about? Gee, my brain is not working. The range is just the same as the range of the base function, -pi on 2 to pi on 2. Fantastic. There's a bit about domain and range. Get used to doing those as well. They come up, they love those in exams, just love them. They'll say, find the domain and range, and then they'll say sketch it. They'll always get you on those. Lastly, I hope I've got time. I'll just check my time because I just can't go over. I've got heaps of time. Lastly, let's just do a couple of these sort of little funny sort of things. Sine -1 of cos 5 pi over 6. Okay, these tend to come up from time to time. There's easy ways, hard ways to do these things, but probably the only sure way is just to be careful when you take it one step at a time. Sine -1. Let's just figure out firstly what cos 5 pi on 6. 5 pi on 6 is here, okay? Cos 5 pi on 6 is there. And so it's the symmetry for that there of cos pi on 6. Cos pi on 6 is √3 on 2. But cos over here will be negative, okay? Because we're talking about the x value, cos. So what that's going to be is going to be -√3 over 2. Get used to these, please, 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 please. Right, so just to go over then, cos pi on 6 is there, and that's √3 on 2. But this is, we want here, the value over here, cos 5 pi on 6, and that'll be negative because it's reflected. Okay, so we've got that. Right, now that we've got sine -1, what we want to ask for is, where is sine equal to -√3 on 2? So I'll draw another circle. Where is sine going to be, where's sine equal to √3 on 2? That happens up here at 60 degrees or pi on 3, okay? But we want sine -1 of that, and just remember, where's our sine -1 function? Must be in those two quadrants, okay? And so what we want is the sine value negative. It's going to be down here, okay? It must be down there because there's a positive y value, there's a negative y value. So the answer will be -pi over 3 radians, okay? Good. One more example. Just do it down here, and this one might trick you. What is cosine, inverse cosine of cosine 7 pi over 3? Now, your first instincts will probably go, well, doesn't just the inverse of cosine multiplied by the cosine of 7 pi on 3, won't that just undo each other, and won't just the answer be 7 pi on 3? Isn't that just that simple? And the answer is, sometimes yes, that will be the case. But just remember that the cosine inverse function here returns a value that's only in two quadrants. And so it will only give you, this value will only be equal to that if it lies in the, well, for cosine, it's defined just in those two quadrants, okay? So if it's in those two quadrants, yes, that will happen. If it's not, that will not happen, okay? Let me just prove it to you, okay? Let me just get rid of some stuff. Right. Okay. Let's do it. Let's just take it one step at a time, okay? Equals cos -1. Alright, now let's figure out what is cos of 7 pi on 3, okay? So we've got 1 pi on 3, 2 pi on 3, 3, 4, 5, 6, 7. So there's your 7 pi on 3, okay? What's the cos value at that point? Well, the cos value at that point will be half. Okay. Next, cos -1 of a half. In other words, where is your value of cos equal to a half? Well, your value cos of equal to half will be there, just like we just said there, and so it'll be there. And remember, we're only talking about in those two quadrants, but that is correct. Cos, it's positive and in that quadrant, so that is fine. And sorry, I just did the wrong quadrants. It shouldn't be those, it should be those. And so the answer is, what's the answer? It's only in this value, and so it's pi on 3. Okay, so what this inverse is, it returns a value which is only in this range. So if your initial value here is outside of that range, it'll sort of correct it and come back into that range. So you can't always assume that cosine -1 of cosine of some value is just equal to that value. Okay, and we'll leave it there for this lesson.